Good day, good day, good day. Welcome back to our YouTube channel. So with me here, I'm Stiffler. So today we just decided to do a topic on organic chemistry. So today we are focusing on organic chemistry. But I understand that organic chemistry is a bit of a challenge, so you need the simple basics, right? So today I'm just going to give you the introduction on organic chemistry. In this introduction, we are going to be talking about the periodic table and simple stuff that you need to understand on the periodic table and some other things that you need to understand about carbon. So we are going to deal with carbon a lot, so it's important that we talk about this. So this periodic table is made in such a way that electrons are sitting exactly at the perfect place. So these are called groups going down, these are groups across, these are called periods, right? So every element that is in period 1, it means that it was only one shell of electrons, right? The ones in period 2, they have two shells of electrons. So all these other elements from group 2, period 2 up until down, they can be filled with 8 electrons in the outermost shell, right? But hydrogen and helium can only be filled with 2 electrons in the outermost shell, right? So let's talk about this carbon that we are interested in. So this carbon, as you can see, it is in period 2. And it is in group 4. So it is in period 2 and group 4. So in group 4, it means that it has 4 electrons in the outermost shell. And for this to be balanced, it means that it needs other 4 electrons for it to be balanced, to make it 8 electrons. So it means that carbon now, it is having only 4 outermost electrons like that. So obviously it means that it is not balanced, right? So it needs an addition of 4 other electrons. So that's why carbon can make 4 bonds, can make a maximum of 4 bonds. So you have to remember this always so that you won't get it wrong. Carbon always will have 4 bonds, we always create 4 bonds. So other than carbon, we are also going to be talking about hydrogen, right? Hydrogen is in group 1, period 1. It is 1 electron and it needs an addition of another 1 electron. So it means that hydrogen can only create 1 bond regardless of the situation. It will only create 1 bond, right? So apart from also hydrogen, we are also going to be talking about elements in the group 7. These are halogens, right? We are going to be talking about halogens as well. And then group 7, so it means that they need only 1 electron. So for them to be balanced, for them to have 8 electrons, they need only 1 electron for them to be balanced. And also we are going to be talking about oxygen, which oxygen is in group 6. So it is 6 outermost electrons and they will only need 2 for them to be balanced. So it means that oxygen can only create 2 bonds. Other than this, on the periodic table, let's talk about more stuff that are important when you're dealing with organic chemistry. But now I just need you to take away that if you're working with carbon, carbon can only have 4 bonds, because like most of the time we see the mistakes of students having to place 5 bonds on carbon, so which is very wrong. So just be always mindful that carbon will always have 4 bonds and not less and not more than that. Hydrogen, 1 bond. Fluorine, chlorine, bromine, iodine, 1 bond. Oxygen, 2 bonds, right? So let's get straight to other stuff. So organic chemistry It is the chemistry of carbon compounds. So we are going to be talking about carbon compounds a lot. So carbon and hydrogen are the most present atoms in the organic compounds. So we find out that a lot of them, they are made out of carbon and hydrogen. However, we also have other elements including oxygen, fluorine, chlorine, bromine and iodine, right? But if it was not CAPS, we are also going to be talking about nitrogen. But just because this is CAPS syllabus, we don't talk about nitrogen, we only talk about this stuff, right? So carbon is the basic building block of organic compounds, and carbon is mostly recycled throughout the Earth's atmosphere, right? So carbon is present in our bodies, in many minerals that are in our bodies, right? And carbon can also be present in things like plastic, petrol, or like other organic substances. A lot of organic substances are made out of carbon, right? So there are a million of organic compounds that are in the world, right? And this is caused by carbon's uniqueness, right? So carbon has a uniqueness called catenation, right? Catenation, just think about it. Mostly it is asked in the exam, right? Catenation. So catenation is the ability of carbon atom to form very long chain with its own atoms. So carbon can make very long chains with itself. This is termed catenation, right? So just see some way to write it down. So it can form a very long chains, branches, or rings. Just like I explained again, this is CAPS, so we don't talk about the rings, right? We are only going to be talking about long chains and branches, right? Yes. So these carbon atoms can make single bonds between themselves. As you can see, this is just single bond between the carbon atoms, or it can make double bonds. This is the situation we're having, double bond. Can you see that? And also they can make triple bonds between carbon atoms, right? And so we are going to learn the difference in this kind of stuff as we proceed in the organic chemistry, right? But this is just to show the uniqueness of carbon. So carbon can make single bonds between their atoms, or double bonds, or triple bonds, just like that, right? So as you can see, our carbon to carbon bonds are unique, right? So from the previous one, let's just conclude, or let's just summarize like this. So carbon to carbon bonds are unique because the covalent bonds between carbon atoms are quite strong, right? They are quite strong. So this makes the carbon to carbon bonds unique, or this makes organic compounds very unique, right? Carbon compounds are not extremely reactive. Obviously, if they are not extremely reactive, it means that they are a bit stronger, and they can stay for a long time without changing the way they are, right? And a wide variety of compounds are possible, since carbon can form up to 4 single covalent bonds. Like we said, just because carbon can make 4 bonds, this makes it so much special, because just think about the way that, or the different types of arrangement that can happen with other atoms, right? Which will make different or more compounds like that, right? And also the ability of carbon to make bonds with itself, like we said, the property called catenation. This also makes the carbon to carbon bond unique, right? The ability of carbon to make multiple bonds with itself. We also talked about this, right? So now let's go a bit further and describe some other things that are going to help you when you are dealing with organic chemistry. Like I said, this is just an introduction, so I'm just trying to pull some important factors or some bit of facts that can help you in the organic chemistry, right? You don't have to be scared about this. Organic chemistry is enjoyable once you grab the basics. So the important thing is to grab all the basics, right? So also you need to learn about how to represent organic compounds even before we can start with organic chemistry, right? So there are 4 ways in which you can represent organic compounds, right? So the first one can be the molecular formula, right? The molecular formula. So how is the molecular formula? The molecular formula is simply just maybe something like this. So this is the molecular formula. So the molecular formula just shows us how many of each atom are in the bond, right? They're in the compound. So this shows us that we're having 4 carbons and 10 hydrogens, right? That's how the molecular formula works. It's just as simple as that. No further details, just showing you how many of each atom are in the compound. And then from then we have the structural formula. So the structural formula, if you are trying to draw the structural formula of this, it will be C, 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 something like that. So this is the structural formula. Structural formula. So this shows us the structure, right, of the compound, right? This shows us the structure of the compound. That's the structural formula. And then apart from that, we also have the condensed structural formula. The condensed structural formula. So if you're trying to draw the condensed structural formula, it actually shows us each and every carbon and what it is bonded to, right? That's the condensed structural formula. So we start with this first C. As you can see, this one is bonded to 3 hydrogens. Can you see that? So we can place our hydrogen, and then the next C there, it is bonded to 2 hydrogens. So this is just H2, and this one also it is bonded to 2 hydrogens. So this will be C, H2, and then the last is bonded to 3 hydrogen, like that. So this is what you call the condensed structural formula, right? So the condensed is more about what is bonded to which carbon, right? So as you can see that this is bonded to 3 hydrogens, this to 2 hydrogens, this to 2 hydrogens, and the last one to 3 hydrogens. That is the condensed structural formula, right? So the other way that we represent organic compounds is by its IUPAC name. Its IUPAC name, which this is the most hardest thing to do when you are dealing with organic chemistry, right? But I'll simplify that for you, right? So that's how we name compounds according to the international system, right? I'll show you how to do that. I'll give you the rules when we start with our organic, right? So as I said, this is just the basics. So now you can see how to represent these organic compounds, your molecular formula, your structural formula, and lastly, your condensed structural formula, right? Yes. So now I'll talk about the last thing before I can just cut this video to start up with our organic chemistry now, right? Yes. Okay, so last but not least, right? So as you can see, I drew 3 different compounds there, right? So this is to emphasize on something that I want to explain now, right? So through this series of videos, we would study organic compounds that are grouped together, right, with similar characteristics and properties, right? That are similar in characteristics and properties. We'll learn how to classify and be able to differentiate between all the different types of compounds. Here I just draw the 3 different types of compounds, but we can have as many as we want, right? We can also have something like this. You can have something like this as well. So this is another type of compounds, right? So we'll do this by identifying the functional group and the homologous series, right? The functional group and the homologous series. Let me just write them here. So we'll find the functional group. So what is the functional group of a compound? So the functional group is an atom or group of atoms. So it's an atom or a group of atoms that forms the center of chemical activity in the compound. So that is a functional group, right? It is an atom or a group of atoms that forms the center of chemical activity in the compound. Let's take a look at this one. What can you observe from this one? Can you see that there's only single bonds between the carbon atoms? It means that this is the functional group of this type of organic compounds. And we move to this one. We can see that this is a double bond. Can you see that? So this will form the center of chemical activity in a compound. So it means that also this is the functional group of this type of compounds, right? When we move to this one is having a triple bond. Can you see that? It is having a triple bond. So also in this case, this is the functional group to this type of compounds. And when we move to this one that I just drew now, we can see that we're having this type of thing, the OH at the end, right? So also this OH, you can see that there's no OH in this compound. So also this is the differentiating point from this and this and this. So this is the what? The functional group of this type of compounds, right? So now when we differentiate between the functional group now, it means that this, just because it is having a different functional group to this one, it means that this will belong to its own homologous series. To its homologous series. So what is the homologous series now? So the homologous series is a series, or it is a group, right? So this is a group or a series of similar compounds that share same functional group, that shares the same functional group, that is the homologous series. So it means that this functional group gives us the definition of this, or these functional groups helps us to understand the homologous series. So once we get into organic chemistry, you understand which falls in where, right? And it's so much joyous to study. So I just want to leave you with this functional group. Can you see the difference? This is the functional group, right? So it means that this falls in its own homologous series. This falls in its own homologous series, and also this falls in its own homologous series, as well as this one. I hope you enjoyed this session. I did enjoy myself. So the only thing that I would want to beg from you is to please like, share, subscribe, and also please tell your mates about this, right? Tell your friends about this, so that the family can keep on increasing, right? I love you, and I'll see you on the next one. Don't forget, my name is Stiffler. Goodbye.